So on the agenda for today, I'm going to go through the last couple, or the things we'll be doing for the last couple days of class. I think we have something like 6 class periods together until the end of the semester, so keep that in mind. We're going to go over assignment 6, and I'm going to talk about a couple assignment 7 concepts. So before we get started, any questions or comments?
No, sir.
Okay. So, course schedule. So, like I was saying, today is the 13th. We have next week, so 16th, 18th, and 20th together. The 23rd together. We're off for Thanksgiving. We have the 30th, the 2nd, the 4th, and the 7th. This Wednesday, the 9th, is off. So we have a day off between the semester and finals period, and then the final for this class is on the 11th. So that is in 1, 2, 3, 4 weeks.
After the 11th, you don't have to go to class anymore?
Nope, we are all done after the 11th.
So is the 11th the last day for all classes?
Nope, just for this one.
No, it's the exams after that Wednesday. So there
Yep,
will be one exam for class, and after that you're done.
Yep, we just get lucky, and our exam gets to get scheduled early for this class. So that's what we're looking at. So
Cumulative exam, or is it just like
yes,
or like
it's exactly so. So I'll talk about that. So so the things that we'll be doing before the end of class, or before class finishes, we're going to be completing assignment 7. So I'm probably going to give you quiz 4 next week, dealing with arrays. I'm also going to be giving you the DSC Tech exam next week. That deals with CSC 150 and 105 concepts. And then there's 2 more assignments, which I will be giving you to work on the 30th, and then have them completed by the 8th. So this week right here is basically just going to be a week for you to work on these 2 assignments. So I'm going to give you an assignment on building and manipulating strings, and give you an assignment on a survey of programming languages. Now, what I want you to do for that survey of programming languages assignment is I'm going to give you a simple task to do. Might be exactly one of the assignments that we've done before. And what I want you to do is go through and select 5 or 6 different programming languages and implement this in that language. So I don't want that to be particularly difficult. The assignment shouldn't be that hard, the actual task, but I do want you to look at a couple different programming languages just to think about what they do and get acquainted with them. And then finally, the final, which again will be on the 11th at I believe 10:30 a.m. I'll have to tell you that more specifically in the future. But that final will just be like our other tests we had for our midterm. It will have a D2L component and an in-class programming component. The only difference is you will have the entire 2 hour, or our final period is 2 hours, so you'll have the entire final period to work on it. Generally, the structure of that should be, I'll give you the D2L component, and then as soon as you're finished with that, you can work on the in-class programming for as long as you want. So realistically, if you know exactly what's going on, the in-class programming component shouldn't be that hard. It should take you about 20 or 30 minutes to work on it. So that's our course outlay. So I wanted to let you know what things you should expect in the final weeks of this class. So I'm going to go over something else. So I'm going to go over assignment 6 then. So remember assignment 6, we need to, let's actually go look up what the exact description is. So we are creating an array with n number of elements, generate n random integers 0 through m, and store them in an array. Then calculate the following items: sum, min, max, mean. So I'll go through that really quick. So there's a couple things in my assignment that I decided that I was going to change around, but I haven't had time to yet. But I will go through this assignment in general. So what I did for this, so the first thing I did was I initialized our random number generator. I created 4 variables, one for the size of the array, one for the maximum number that will be generated, one for the result from function calls for integers, and one for decimal results from function calls. So then I read in the 2 numbers. I created an array of size n, which again is the size of our array, And then I just, inside the main program, I looped from 0 to n, and I filled up the array with random numbers, which are limited by m, which was read in up here. So then I went on to call the 4 functions. So I did sum, min, max, mean. So the way that I did mine, I meant to restructure this, but I'll have to go through and change it a little bit. So the first one we did was sum. So when you're doing sum, you create a function that passes in an array, and it passes in the number of elements in that array, and it returns the sum. So I create a variable called res, which will store the sum, and I create a variable called I, which will be our index when we're navigating through the array. So we loop from I to n, and we just say res plus equals array at position I. So that will take every single number in the array and add it to I, or add it to res, and then it will return res. So continuing on to min. So this is the one I need to restructure a little bit. So I'm going to just ignore this right now. That's not what I want you to think about. So when we're doing minimum, the way we would go about doing that is we'd grab the first element of the array, and then what we do is what I did is I created 2 variables, I for the index and c to temporarily store the value in the array, and then looped from 1 up until n. So the basic logic of this one is we're going to store the value in array at position I and c, just so we don't have to reference array at position I twice. And then we say if c is less than res, which is our current minimum value, then we set res equal to c. So we're just going through the list. We're going to assume that the first element of the array is the smallest element to start out with. And then if we find another element which is smaller while we're traversing the array, we're going to set res equal to that. And then finally, res will contain the minimum value and will return that value. So moving on to max. Again, I'm going to change this to the way I'm assuming most of you probably did it. So again, setting res equal to the first element of our array, we're assuming that the first element of our array is the maximum number. Then we're starting at position 1 and looping up until, or from 1 to n. So again, we grab array at position I, store it in c, and if c is greater than res, then we know we found a new maximum. So we set res equal to c, and then we return res. So finally, for mean, it's pretty simple. So we have another variable called res. What I did there is, instead of rewriting the logic, remember we can call functions inside other functions. So what I did is said res equals sum, and then just passed in our array and our number of elements. And then based on the sum, in order to get the mean or average, all we have to do is take res and divide it by n, because the way we get mean is we take the sum of all numbers and then we divide it by how many numbers we have, and then we return result. So that was my assignment 6. Any questions about how you should have gone about completing assignment 6 or anything else? All right then. So on to assignment 7 stuff. So a couple things about assignment 7. I've decided to change a few things around. So due dates, everything is pushed back slightly. So take a look on D2L, take a look on dev.dsunix for the exact information. So I've also tweaked the program requirements a little bit, hopefully made it a little simpler. So with the program requirements, you'll only need to shuffle 1 deck, and you'll only need to play with 1 player. So that does take a lot of the work out of things. It still leaves a lot that needs to be done, but it does take those things out. If you do manage to complete those, though, I will give you 5 bonus points or something like that. So remember that the first thing that is due which is now due on Sunday at midnight, is the shuffle print. So I want you to fill an array with unique random numbers from 0 to 51 and loop through that array and print off the rank and suit associated with that value. So that's pretty much what we're gonna. Oh, I forgot. So I also want you to submit a plan about how you're going to approach this problem, because when we start to write bigger programs, it gets really hard to just sit down and program something. You really should think about what data or how you're representing data in your program and how you're processing it. So I'll give you a couple hints on how to approach both of these today. I'm going to go through a couple of different concepts that I think are really helpful. So, like I said, I'm going to cover 3 different things today. So I'm going to talk about filling an array with unique random numbers. I'm going to talk about card representation, so getting suit and getting rank based on something, or based on an integer that you generate between 0 and 51. And I'm going to talk about traversing an array one position at a time. So the first thing I'm going to talk about again is array with unique random numbers. So we're basically going to create a function, and we're going to pass in array size, or the array, the size of the array, the maximum value that we want generated, and the number of times we want to see a number appear when we're generating it. So inside that function, we want to create a array size. So we want to create an array of size max value, not limit. And that will be used to count variable usage. So when we generate a number, we check if usage at the generated number is equal to 1. If it is, then we've used it before, we need to generate a new number, or else we set it to 1 so we don't have to use it again. So I think I did most of this program on Friday, or Monday, what am I saying? So unique random. So I'm going to change this around a little bit so it's a little more versatile. So remember, the couple things that I said I wanted to pass in was array, size, max value, and usage limit. So we'll take another parameter called int max and int usage, or int limit. So I'll start at the top here. So the first step we need to do is create an array of size max value. So we just say count max. And remember, one of the things I talked about before is that if we have an array and we specify the size on runtime, we have to initialize it in a slightly different way. So remember, we have our init function. This takes an array, and its size, and the value we want to initialize to. And we loop through that array. And for each position, we set array at position I equal to the value we want to set it to. So we can initialize an array by calling this function. So we want to set count to 0, so we would say init count size, and we want to initialize it to 0. So now that we have our usage array, it's initialized to 0, we can start actually looking at numbers. So again, what we do is we have a for loop where we want to loop through each element of our array, and we want to generate a unique random number for each position. So what I did before, remember that if we wanted to do something like this, this would generate random numbers purely between 0 and 51. But those numbers aren't guaranteed to be unique. And the whole reason that we have to do things like we have to have this count array is so that we're checking to see if the numbers that we generate are unique. So what I do is I put that statement inside a do while loop, and we check to see if res is, or we don't do that, we do count at position res less than limit, or equal to limit. That's what I'm thinking. So let's say we want one occurrence of each number that we want generated. So we pass in 1 for our limit. So the first time that we're going to come through here, let's say we're at position 0 and we generate a random number, and that number happens to be 1. So what's going to happen is it's going to take that number, which is stored in res, which is 1, and it's going to go into our count array, add position 1, which is going to be 0 since we just initialized everything to 0 up here. And it's going to see if that is equal to limit, and limit is 1. So what's going to happen is this statement's going to be true, and this do while loop is immediately going to exit. So then what's going to happen next is we want to set our count at position res, or we want to increment that, so that we know that that number has occurred once inside of our array, and then we want to set the value in our array at position I to the result from our random number generator. So that might make sense to some of you, might not. I'll admit my explanation isn't the best of how to do this, but maybe tinker around with this code, write it out, and see what happens. So again, when we're calling this function, we have to change it around a little bit to account for the size and max change. So let's say we wanted to generate 20 elements, and we wanted our maximum number to be 10, and we wanted the limit on occurrences to be exactly 2. So we'll have, I didn't change this around here. I need to change this to max here. So this will generate, inside our function, it will generate 0 through 9 random numbers, and those 0 through 9 numbers can occur exactly 2 times. So that's about all I had for filling a random number. Definitely get started working on that and ask me questions as you progress. So next thing I want to talk about is card representation, which hopefully is a lot more interesting. So taking a look at these cards, I've gone through and I've numbered the entire deck of cards. So I've numbered from 1 to 52. So just thinking about this is kind of how I want you to think about how the cards would be represented by the system. So when we're generating a number, we would generate, let's say, rand mod 52, which will generate 0 through 52 numbers. And each card will be assigned a number in our heads. So just one note, though, quickly, my numbers are off by 1. So the program I used to make these numbers really nicely only allows me to start at 1. So realistically, this ace should be 0, and this king here should be 51. But I couldn't do that. So just think that the cards are actually numbered. In order for this system that I'm going to describe to work very well, the card numbering really should start at 0. It's possible to do it starting at 1, but it really isn't the best way to do it. So again, assigning a number to each card. So one of the things we talked about before is modding, or dividing and modding a number to get its position and things like that. So one of the things we can do is, based on the number that the card, the number associated with the card, we can divide and mod that number to get the rank and the suit. So if we wanted to get the rank of a card, what we can do is we can take the card number and then mod it by 13. And if it's an ace, the result will be 0. If it's a 2, the result will be 1. If it's a 3, the result will be 2, and so on and so forth. Now, if we wanted to get the card rank, what we can do is we can take the card number and divide it by 13. So if it's a club, then we let's say it's any of these numbers, which are 0 through 12 in my example. So we take that and divide it by 13, we get 0. But as soon as we go on to the next one, so this would be 13 here, and we divide that by 13, we get 1. We go up here and we take 26 and divide it by 13, we get 2. And we take this one up here, which is 39, and divide it by 13, and we get 3. So these ranks, or these suits can be in any order. They don't necessarily have to be in this order, but you do have to account for how they represent it in your code and which numbers are associated with them when you're writing your program. Yep.
Couldn't we also do it so like 1 through 4 aces?
I mean, this is just an example of how I wrote it in my program and how it made sense to me. But yeah, if you already have another way done or have another way planned out on doing it, by all means, feel free to do it. So, and then based on that representation, so I'd write a function to print an individual card. So in that function, I would have a switch statement or a bunch of if-else-if statements for rank. So you would switch on card mod 13 and then have a bunch of printfs inside there. So you'd have a printf for 0 to print, or you'd have a, let's say, case 0, and then you'd printf ace, you'd have case 1, you'd print f 2, and so on and so forth. And then between these switch statements, you have printf, and you just have of, and then you have another switch statement for suit, so that would be card divided by 13. So that's how I go about doing that. So the final thing I wanted to talk about today was traversing an array one position at a time. I'll just stay in my... No, I'll make a new one. So one of the things we want to do, especially when we are dealing out cards and shuffling, is we want to work one position at a time in our array. Now, there's a couple different ways to do this, but the ways that come to my mind at first aren't exactly something that I can show you. So I'm going to show you, it might feel a little bit backwards, but a way that you can implement traversing one element of an array at a time using your knowledge of C. So we're going to make an array, my array. I'm just going to give it a couple elements, just statically like this. I'm just going to say 1, 2, 3, 4, 5. And then that is 1, 2, 3, 4, 5 big. So I'm just going to say n equals 5. So one of the things that you'll need to do a lot is keep track of which position you are in, let's say, a deck. Let's assume this is a deck, but there's only 5 cards. So we'll have a variable called index, and that will keep track of which position we are currently working on, or which position is the next position we can use. So let's say I take a card and I give it to a player. Let's say my function is deal card, and I have 2 arrays. I have my array, and I have n, which is my size of my array, and I have player, and I have player index. Now, what this function is going to do, just thinking about it, it's going to take the next card from my array and give it to the player. So one of the things I'm also going to have to do is I'm going to pass in the index of my array, which I'll just change this to deck because that'll make more sense. And I'll change this to deck index. So, when
You deleted n.
I did do that, didn't I? So I'm not going to give you exactly how that function would be implemented, but essentially what we'd have to do when we're doing this function is we'd have to return the new position in the deck. So we'd have to say something like this: deck index equals deal card, so that we know where we're currently at in the deck. So I'm going to go back. I'm actually going to do it slightly differently. So let's just say we wanted to traverse this array one position at a time. So what I would do is I'll make a function called increment print, and it will take our array, and it will take how many elements that are in our array, and it will take the index. So all this will do is it will printf the position of the array and the value of the array. So we get the position of the array by the index that was passed in, and we get the value of the array by saying array at index. So after we've incremented this, or after we printed it out, we want to return the new index that we're using in the array. So we would say return index plus 1. So what this is going to do is going to essentially help us track where we're at in our array. So we pass in our array, we pass in the size of our array, we pass in the index of our array. So right now what this will do is it should theoretically just print 1. And I have to remember to return 1 or return 0 in our int functions. So that will just print 1. So I'll just duplicate this a couple times, and I'll run again. It should continue to just output position 0 at 1. Okay. So what's happening right now is we're ignoring the return value from this function. So what this function returns is the index plus 1, so we know what the next position in our array that we can use is. So what we need to do is we need to assign deck index to increment print. And what that will do is when we call this function, we'll pass in our deck, the number of elements in the deck index, and the deck index will be incremented by 1 and returned, and then stored in the deck index. So what this should do is, if everything's proper, it should be 1, 2, 3 now instead. Yeah, so 1, 2, 3. So one thing that's better about this approach than, let's say, a for loop is what we can do is sometimes we just want to see what card is at a certain position. Let's say we just want to see what card is at position 4. We can have the functionality to increment the index, but we ignore the return value, so we just would look and see what's at position 4. So at position 4 is value 5. Again, we can kind of put functionality into one spot that we don't necessarily have to, so that we don't necessarily have to write it again. So traversing the deck, that's really important because when we deal a card, we need to keep track of where we're at in the array, so that when we come back and we deal cards to the next player, we are still keeping track of where we are at in the array. So some concepts that you'll get to tinker with a lot when you're working on this assignment. So that's all I have for you today. If you are unsure about how you're going to complete the assignment for Sunday, I definitely recommend you stick around and work on that for the time being. Otherwise, if you're basically done with that, feel free to take off if you'd like.
So the assignment for Sunday is basically what we did Monday class.
Yep, pretty much. Carter, stick around.